Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Luqman bin Ahmad Tarmizi from BMMD Section 1 Group 1. Today I would like to present to my panel about my bachelor degree project PSM 1 about an analysis of low-end additive manufacturing machine. Firstly, I would like to present my main supervisor, Technologist Dr. SHAHIBUDIL IHKWAN bin ABDUL KUDUS, and my co-supervisor Technology Dr. HAMBALI bin BOEJANG. Okay. In this presentation, I will present about the introduction, literature review, methodology, and expected result. First, introduction. Study of the dimension accuracy is achieved by various rapid prototyping method have gotten a lot of interest. However, because of 3D printing is such a new technology, there are only a few published research on the dimensional precision or dimensional accuracy achieved by the procedure. Various rapid prototyping processes, including 3D printing, have been compared in a few review studies. According to the Pilho et al. 2014, they state that improving dimensional accuracy is one of the most important scientific issues for additive manufacturing to improve product quality. Next, the problem statement in this project, the dimensional accuracy of low-end additive manufacturing machine in Jabatan Teknologi Kejuruteraan Mekanikal dan Pembuatan JTKM JTKP laboratory is unknown. From that, two objectives have been provided, which are to design the test model for prototype fabrication, and the second one is to analyze the dimensional accuracy of the test model. Based on the objective, 4 scopes has been provided, which are to study the type of computer-aided design CAD file, to understand the process of additive manufacturing, to find the dimensional accuracy in previous researcher, and the last one to design the test model. Literature review. CAD file. What is CAD file? CAD file is a computer-aided design, which are the process of designing and documenting a product using computer software. In this slide, I choose 3 CAD files, which are Standard Triangle Language (STL), Initial Graphic Exchange Specification (IGES), and the last one is Standard for the Exchange of Product Model Data. The advantage for the STL file is file format that is widely supported. Which means this file is support many software. And the second is popular use for 3D printing, and the disadvantage is it just describes the surface geometry and very basic data model. For IGES, the advantage for IGES, it has wide adoption and comprehensive coverage because it is all file. The disadvantage of the IGES file, it does not have a formal information model. Second, does not support lifecycle information, and the third problem may occur during file exchange and manipulation. Next step, the advantage for step file. This file format is accepted in most modern CAD software such as SolidWorks and other. Then disadvantage for step, slow to release new update in this format. For additive manufacturing. In this slide, I 6 additive manufacturing process, which are stereolithography SLA, photopolymer jetting, selective laser melting, selective laser sintering, fused deposition modeling, and laminated object manufacturing. Okay, for material base, liquid, stereolithography, and photopolymer jetting. Okay. Stereolithography, it uses low power laser and photopolymerization to turn photosynthesis liquid into 3D solid polymer layer by layer. And for photopolymer jetting, it's a combination of two techniques, which are inkjet printing and SLA. Okay, for SLA disadvantage, capable of producing object of higher detail and accuracy. The product produced is high precision and a smooth finish. And this disadvantage, low tensile strength of material and degradation of photosynthetic material result in low performance under load. Okay, for photopolymer jetting advantage, can produce very good accuracy and surface finish, and ability to create functional graded part with multi-material printing. And disadvantage for photopolymer jetting, the features, detail, and material properties are not as great as SLA. Slow recovery rate from high loading condition. Okay, for material base, there are two types: selective laser melting (SLM) and selective laser sintering (SLS). Okay, the advantage for SLM, large range of metal available, ability to realize complex shape or internal features, reduce lead time due to no need for tooling, but consolidation, allowing the production of multiple parts at the same time. And the disadvantage, specialized design and manufacturing skills and knowledge needed, limited currently to relative small part, and rough surface finish, lot of processing required. For SLS, the advantage can print multiple parts at once due to the large build area. Regardless of the geometry of the part, no additional support material is required. And the disadvantage, it requires advanced technology, and the product produced is raw surface finish. Okay, for solid base, FDM, fused deposition modeling. The advantage of FDM, it can be easily scaled to any size, and the cost of product is depend on size and the design. Okay. Disadvantage, low quality and detailed product. It is less durable and unsuitable for several use. Poor surface finish compared to polyjet and SLA, as I mentioned. And the last, laminated object manufacturing (LOM). The advantage of LOM, it has a high speed process, low cost material, part can be used immediately after the process. Okay. And the disadvantage of this process, the scrap material need to remove frequently. Limited material set, and need for sealing step to keep the moisture out. Okay, for the dimensional accuracy, based on Kushagra and Santosh 2018, they studied about the influence of orientation and the effect of support features on dimensional accuracy, where discovered as a factor that affect the dimensional accuracy of item produced by FDM, fused deposition modeling. Okay, printed with PLA. And second, Smith et al. 2016 study on the dimensional inaccuracy caused by electron beam melting (EBM) additive manufacturing. And third, Asmaidin et al. 2020 studied about the dimensional accuracy of ultrasonic assisted fused deposition modeling (FDM) system printed specimen. And the last one, Yoshiki and Taira 2016 study about dimensional accuracy of dental casting pattern created by 3D printer. Okay, For the model, according to my co-supervisor, Dr. Hambali, 2021, during our discussion, he mentioned that during his work with Proton, there are some problem happen with SLA machine, so it need to be calibrated for checking. Then service engineering from 3D system was a person in charge in checking the machine had built the service engineering built the Christmas tree model. Okay, based on this, my co-supervisor advised me to create this model as a test model. Okay, the test model. The Christmas tree model that I will make has several features that need to be considered for analysis. Okay, I will explain my model. Okay, this is my model from CAD software from SolidWorks. Okay, the features that have in this model are cylinder, hole, and the triangular shape. Okay, for this cylinder, okay, where the for cylinder, I will measure the diameter and the diameter. Okay, for the hole, I will measure the depth, and the whole cylinder, I will measure the external diameter and internal diameter, and the last one, angular shape, I will measure the angle. Okay, for the methodology project, this is a project flowchart. Okay, from start, I will gather the literature review and find the information about my project title. Okay, the literature review is done by systematic approach, and the information is gathered from Mendeley software, Google Scholar, ResearchGate, and other websites. Okay, the information that I found is use the keywords such as additive manufacturing, dimension accuracy, and others that relevant in this project. Okay, the paper and journal that I prefer is from 1999 and to 2021. Okay, this is because below the 1999, the theory is not reliable. Okay, when getting the information, I proceed to the next stage, which are to design a test model. Okay, as I show before, okay, this model I create based on my supervisor advice, the Christmas tree model that has a few features like cylinder, hole, and triangle, angular shape. Okay, this model will be designed in SolidWorks software. Okay, after design the test model, the file will be create is STL file. Okay, in STL file, the STL file will be checked by Magic RP software, either is okay or not. If not, I will check my design. If okay, yes, and then go to 3D printing or additive manufacturing process. Okay, in additive manufacturing process, there are two brand low-end additive manufacturing process will be used. Okay, to check the dimensional accuracy. Okay, the brand is unknown due to cannot access the lab. Okay, after that, the machine will be print the prototype, and this prototype will be used to analyze the dimension of the model. Okay. In analyze the data from the CAD and the model will be used for calculate the percent and calculate in the percentage. Okay. Okay. For the expected result in this project, the result is unknown due to the test model has not been printed yet through the machine in the faculty lab. However, here I show the from the previous researcher Asmaidin et al. 2020. They study about the dimensional accuracy of ultrasonic assisted fused deposition modeling system printed specimen. Okay. Okay. They design the model using a CATIA software. Okay. And these are the dimension they test for dimensional accuracy, which are thickness, corner radius, angle, chamfer, perpendicularity, hole diameter, flatness, weight. Okay. And the specimen, after specimen is printed with the FDM machine, they check the specimen dimension accuracy with the CMM, which are coordinate measuring machine. Okay. And in this table, it show two type of material they use for their experiment, which are ABS and PLA. And 4 type of frequency was set: 0 kHz, 7 kHz, 15 kHz, and 20 kHz. Okay. Okay, for the conclusion, the frequency that is set at 20 is result in drastic improvement of dimensional accuracy for PLA specimen. In contrast, for ABS specimen, the ultrasound frequency at 7 kHz and 15 kHz affect the improve only the thickness accuracy. However, all other geometries fail to meet the expected dimensional accuracy. And final, the application of ultrasound does not result in any significant change in the dimensional accuracy of 3D printed specimen in ABS material. Okay, that's all from me. Thank you for having time. Okay, Assalamualaikum.